Imagine we have an input, which is the data we are passing through our neural network, represented by X in the diagram. In a traditional neural network, this input would go through several layers, each transforming the data step by step to learn increasingly complex features. Now in ResNet, we introduce something we call residual block, which you see in the diagram has two main paths, the identity path and the main path. The identity path is the shortcut that skips over one or more layers. In the diagram, you see the input X moving along the top and bypassing two layers below. This is where the term identity comes from, because it's the unchanged version of the input, its identity. The main path here goes through transformation by passing through layers, such as convolutional layer, indicated simply as layer in the diagram. In a ResNet, we usually have pairs of convolutions followed by batch normalization and a ReLU activation function. The output of this transformation is represented by f of x, which stands for the function learned by the layers applied to the input x. At the end of the residual block, we combine the output of the main path f of x with the original input x, which has traveled along the identity path. We add them together. This is indicated by the plus sign in a circle. This idea is that f of s learns the residual, or the difference between the input and the desired output. Adding s back in is like saying start with the original information and adjust it based on what we've learned. This structure helps with a common problem in deep neural networks called the vanishing gradient, where the gradient, which tells us how to update our network parameter, gets smaller and smaller as we go through the network during training, making it hard for the early layers to learn. By adding the input x back in after a few layers, we ensure that the gradient can flow through the identity path without diminishing. This helps the network to continue learning even when it's very deep, which is why ResNet can have many layers like ResNet 50 or 100 and still be trained effectively. In summary, a residual block allows network to learn the residuals or changes needed from the input data to get closer to the desired output, and the identity shortcut helps to preserve the gradient through the network.